Hi, I'm Kripa Patel. I'm the Trash Free School Coordinator at Alice Ferguson Foundation. Today, as scientists, we're going to talk about trash and its impact on our environment. You have probably seen trash in your community and you realize that it is a problem. These observations that you made about trash is the start of a scientific process. And you've probably had a lot of questions like, where does this trash come from? Where does the trash go? And what happens to all that trash when it's just out there? This is part of our research. Scientists make these observations, collect data, and research on finding solutions. So let's do some of our own research of how litter moves around the environment. Overflowing trash bins easily contributes to litter issues. For example, in public spaces like shopping centers, there aren't enough trash receptacles and they can easily get filled up faster than they can get cleaned out. Wind carries trash items out of the receptacles and into the streets, or super strong storms can knock down bins, blow trash into the trees and other places in our environment. In the middle of the night, animals searching for food can be attracted by the smell trash and recycling bins give off from the leftover food thrown away, as you can see. And as it searches, pieces of trash gets tossed out, or maybe it will attempt to eat some of the trash that smells or looks like food. Some trash is bound to fly out during collection process. Washing machines sheds fiber from clothes, which gets washed down the drain and into our waterways. Littering, where people dispose of trash where it doesn't belong. And lastly, the trash that made its way into our environment ends up as runoff in our stormwater when it rains. All rainfall that hits on top of this hill will flow down to that river. That river is called the Potomac, which will flow into the Chesapeake Bay and then into the Atlantic Ocean. And as water travels, it collects trash and moves it along from one place to another. So what happens when trash is out there? Samantha Battersby is going to lead an investigation on trash and its impact.
All of these items are common items that we find during cleanups throughout the Potomac River watershed. So what happens if we just leave these items there? What do you think would happen? Does anyone know what decompose means? Decompose means to break down. So how long is this going to break down in our environment if we just left it there? Will it stay there forever? Let's find out. Alright, so for this activity, once you have all of these supplies, we're going to line them up from the least amount of time to break down to the most amount of time to break down. So what items do you think will break down the fastest if we left them in the environment and did no cleanups? Alright, now that we have everything lined up, let's go over this. From the least amount of time to break down to the most amount of time to break down. So first up, we're going to have our paper towel. This takes about 2 to 4 weeks to break down if we were just to leave it in our environment and never pick it up. Our newspaper takes about 6 weeks to break down. Next up is going to be our cardboard box. This takes about 8 weeks to break down. Now, after that, things get a little more tricky. Next will be our cloth, but depending on the type of cloth, it's going to vary on the time it'll take to break down. So this organic piece of cloth is going to take around 2 to 5 months to break down. But something like my t-shirt could take up to 50 years to break down because of the plastics that are in it. It's got polyester and nylon. So after our cloth, we've got our plastic bag. This takes about 10 to 20 years to break down. Now the interesting thing about plastic is that it never truly disappears. It just breaks down into smaller and smaller pieces, known as microplastics. Next up is going to be our tin can. You'd think that this would be after our aluminum can, right? Because of how thick it is. But this takes about 50 years to break down, and you can see it's already rusting. Next up is going to be our foam cup. Now remember, styrofoam is a type of plastic, so like the plastic bag, it'll just break down into smaller and smaller pieces. This takes about 50 years to break down as well. Next up is our aluminum can. This takes about 200 years to break down. But the great thing about aluminum cans is that they can be recycled an infinite number of times. So if I were to recycle this aluminum can today, in 60 to 90 days, it'll be back on the shelf as an aluminum can. Next is going to be the plastic water bottle. Now this takes about 450 years to break down, and unlike our aluminum can, will not be recycled an infinite number of times, if it even gets recycled. These will also never be a plastic water bottle again once it's recycled. They'll turn it into something new. Next will be our fishing line. Now you would think something this small would break down a lot faster, but it is really strong. In fact, during a lot of cleanups, I have to bring scissors with me to cut this off of rocks and tree limbs because I cannot get it off with my bare hands. This takes about 600 years to break down. Last but certainly not least is our glass bottle. This can take up to thousands to millions of years to break down if we just left it in our environment. So here's our trash timeline. Now that we've investigated how trash ends up in our environment and its decomposition rate if we just were to leave it in our environment, what can we do to reduce our trash footprint? A step that we can take is doing trash-free lunch. Here are some easy swaps you can make for your trash-free lunch. Be sure to put your snacks and sandwiches in a reusable container. Bring reusable utensils to eat your lunch. Put your drinks in a reusable water bottle. And don't forget to bring your reusable lunchbox.
Additional steps you can take is researching your local recycling center for do's and don'ts of proper recycling. You can also volunteer at a local cleanup. And for more ideas, check us out at fergusonfoundation.org.